Hi, my name is Tim, and I'm part of the Effect team, bringing you the latest and greatest in Effect. And today, I want to tackle quite a big topic in Effect, which is incremental adoption. And it's definitely quite a common question that we get in the community is, I have this existing code base, and I love Effect, but I got no idea how to get Effect into that code base in a way where I don't have to rewrite everything. And it's a great question, and hopefully today we can cover that for you. So some of the objectives we want to get through in this section is we just want to learn how to get Effect and all its great stuff into like an Express app or an SJS app or a React app, and what that process might look like, and kind of understanding strategies for wrapping like your existing business logic into like Effect services. And we've already kind of covered a bit of that in the previous section. And to gain some experience in like incrementally adopting Effect from like integrating third-party libraries as well as your own internal business logic. And that pretty much is the exact same point repeated. So you want to adopt Effect. Let's say you have a Express app already, and let's say you just want to migrate some endpoints. So you're already using another framework like Express or React or Vue, if you're a Vue user out there. Or you might be using libraries of like promise-based APIs like Prisma or OpenAI clients or whatever it may be. And this is probably one of the key points I want to make. Your existing code generally isn't written holistically. And what I mean about holistically is a lot of existing TypeScript out there doesn't consider error handling like we know and love in Effect, like errors as values and all that hot stuff. It might not consider resource management very well. In Effect, we've just been talking about scope and finalizers. And for a lot of people coming to Effect, that's quite a new thing and something you need to wrap your head around. In Effect, interruption is built in. So in JavaScript, a lot of JavaScript APIs out there, you have like a abort signal and abort controller, but it's quite tedious to use, and a lot of things don't really support it that well. That's another thing we now have to consider now that we are adopting Effect, and observability. Like we do have OTel has released libraries for observability, but they are sometimes quite painful to use. But because Effect makes observability quite easy, it's now something that we should probably be considering when adopting Effect. So when I say holistically, we now have all these new concepts to think about to create kind of like applications that kind of like consider all the scenarios your application might encounter. And this is exactly what I said. I'm just too fast for my slides. So the first thing I want to cover today is wrapping promise-based libraries. So we're going to kind of go on a bit of a journey. Generally, the first thing you want to know is I'm bringing in this code from NPM, and I don't want to rewrite it. So how do I bring it into my app in kind of like a way that I can consume it in my Effect code? So the first thing I want to cover today is a pattern that I call the use pattern. And I use this pattern myself a lot in the apps I write to kind of like, in a very efficient way, bring in a library without having to do too much legwork. And often I'll create an Effect service. Unfortunately, Max didn't have time to cover Effect.service in the past session, so I'll try to give a quick intro when we encounter the code. But essentially, it creates a tag and layer in one pass. So you create your tag and your layer for the NPM package you're using, and you expose a use method, and that use method looks something like this. Let's see if I can get this pen thing working. So this, just to take a note out of Johannes' playbook, here's a red arrow. So this some API interface represents some kind of like client that might be exposed from a npm package that might have like a bunch of promise APIs on it. So maybe that is like OpenAI client. Just pretend some API is OpenAI client. And in our service, we want to have like this use method where you can pass in a function that takes that kind of like external interface, the external npm package interface, and then it returns a promise that returns some value inside of it. And then the final result of this use method is an effect that kind of like unwraps the promise. So this is kind of like the general concept of the use pattern, is creating this method that allows you to kind of like transform promise-based APIs into effects without having to like re-implement every single client method. And it makes it a lot more efficient to like bring in npm packages into your project without having to do lots of work. Next. Technical difficulty. Hey. So to quickly introduce this to you, and this will be a bit quite common in this section, is I'll do a bunch of like coding and try to explain my thought process and show you what these patterns look like in practice. I'll just quickly make sure. How's that font size? It's huge. Is that still quite readable at the back? Thumbs up. Great. So here I have a bunch of type errors. Thank you, TypeScript. You're doing your job. And I have this to do here. Implement the use method. So I'll quickly cover effect.service just because we didn't get the time in the previous session. So you learned about effect.tag, but instead of effect.tag, here we've got effect.service. And things have been rearranged slightly. So before an effect.tag, you'd have something like, and then you'd have the type identifier, and then you would have the interface. But in effect.service, we move it over here and then have like the string identifier right here. So exactly the same, except rearrange a little bit. But the new thing here is the options that it takes. So pretty much here, you can kind of like think of it as layer.whatever. So you have like succeed or .effect or layer.scoped, which we introduced earlier. But instead, it's just like an option key. And then we specify how this service will be constructed. And the nice thing about this is now everything is inferred for you. You don't have to define the shape of your service. It is just inferred by what you return at the bottom here. So if I put foo string, yeah, start type. So we look at of. Oh yeah, opaque types for you. It also generates an opaque type for your service, so you can't see it right here, but maybe if I go OpenAI here. Yeah, there's foo. Because we return an object with foo on it, when we use that service, we now have the shape inferred from the return type. So any questions about effect.service? Who uses effect.service? Yeah, great. That's the best. So we're going to implement this use method now. So the first thing we need is to actually kind of like create our OpenAI client. So maybe we'll just call it client, new API.OpenAI. And here we have our OpenAI client, but it is complaining about a few things. We need to pass an API key. Who here has used the config module? So a few people haven't. What config allows you to do is kind of like access configuration from many different sources. So like here we could do process.env. Something like that. But we have this lovely type of string in undefined. So if the API key wasn't provided, then our program would crash and we wouldn't have a very good error. So instead, we can do something like this. And it's generally a good security practice to use config.redacted for like API keys and things, so it doesn't make it into your like logs. But what this will do is from the environment, read in this environment variable and kind of like unwrap it for you. And a redacted returns strings, but in config you also have stuff like integer, boolean, and it'll just do the right thing. Like read the string from environment variables and kind of like coerce it to the right type. So now we have our OpenAI client. Let's create our use thing. So if we look at from our slide before, we had like client and then the type and then promise A. And we want this to return an effect of A. So we do need to add a generic here for A. So what this allows us to do is we have this client here that we've created in our layer. And the user, when we're using this, we'll pass in a function that takes that client. And then it will then return a promise that we need to unwrap. And usually a good practice, something I like to do is also create an error for our service. So OpenAI error. Error. And usually whenever I start out wrapping a service, I'll just add a cause of unknown, just so we can see like why when this error gets logged for any reason, the original error from the npm library is also carried along with it. And then here we can use it. And I need to add our error type here. So this is kind of like the premise of the use pattern. We now have this method that can unwrap stuff from the npm library. This is what it would look like in usage. Like, actually, signal. So that's a good start. And if we get the signal, it would work. Let's see if I can run that. What is the meaning of life, OpenAI? And it's given us a bunch of philosophical reasons on the meaning of life. Great, thank you. And that's a good start, and that's kind of like what I would use for most npm libraries. So now we've got like this like nice convenient way of getting back effects from NPM libraries and integrating it into our effect code. We've only had to write 5 lines of code to make that happen. We didn't have to copy the entire interface and then turn every single method into an effect. But if we go back to our holistic thinking that we introduced earlier, usually what I do is kind of go through each line of that holistic thinking and then kind of try and consider it in the context. So the first thing is, are we allocating any resources here? So usually when I create the client, I'll be looking for things like, does it have an end method? Does it have a dispose method? Does it have close or whatever? And if it does, then I'll turn this into a scope layer and then make sure that thing is being called. So that would be something like effect.acquire release. That would be effect.sync. And then you would release it. So something it might be a promise. And then you would have client.destroy. But because this particular client doesn't have a destroy or end, we don't need to think about resourcefulness in this instance. The other thing on the list was interruption. So what happens if one of these API calls goes for ages and we want to kill it if we interrupt our program? So the thing you're looking for is, do these APIs support abort signal? So in the case of OpenAI, it does. When you do create, and the second parameter has options to accept a signal. So to support that, we can go signal here, try promise optionally takes in a signal, and then we can pass it along to OpenAI. So this use method now gets a abort signal passed in, and we can then pass it along to the NPM library. So now everything compiles properly, and if we interrupt that, it actually completely stops the HTTP request by aborting that abort signal. So that kind of is a quick overview of the use pattern. Let's go back to slides. So just a recap, we use effect.service for this, and we kind of expose the use pattern to wrap the OpenAPI library. We use the config module to bring in the API key for the client. And usually anytime you need to bring in API keys or URL config, the config module is probably the thing I'd always turn to. I didn't actually use schema.tagged error, so that was wrong. I used data.tagged error. But if for any reason you needed to then send that error somewhere else, schema.tagged error is probably a better option. Maybe I'll just quickly show that. So here we have our data.tagged error. And it's just a matter of changing it a little bit. And then here you would do your schema. And for cause, you can use schema.defect. What schema.defect does is kind of takes an error-ish object and then just kind of serializes it in a nice way. But with that simple change, this error can now be sent over the wire from an API or from whatever. And we can send it from server to client while preserving all of the error information. And we considered interruption in the demo by passing along the abort signal. So just going back to holistic thinking, we've been thinking about interruption, we considered resourcefulness. We added like nice error handling, and we didn't cover observability, but I'll show an example of observability later. Oh, I was supposed to consider it, apparently. So for the observability piece, wait, is there a question? I didn't quite hear you, sorry. This one here. So this is just purely a type signature. Um, if I look at this function here, does that make sense? Cool. So the last piece I didn't cover was observability, and something I like to use is effect.function for this. So here we effect.function, if you haven't used it before, kind of like wraps a function with tracing. So here we can put openai.use, and this will like add a span for us to this function that we've defined. So if we export telemetry to open telemetry OTel, every time we use this function now, we would see the trace in our telemetry backend. And later I'll show that in practice in Grafana. But for now, I'll quickly show you the other way of doing it, the more traditional way, which would be doing a pipe here and going effect.with span. And this is almost exactly the same as effect.fn, but effect.fn does a few nice things in terms of like stack traces that I won't cover today. Yeah, and there was no resources in this instance that needed to be managed. So that was a lot. Any questions? It doesn't really affect performance that much. Probably the most expensive part of it is creating the span itself, because it needs to like um, read like the current time and all that kind of stuff. So the overhead of effect.function isn't massive. It does have to generate like a stack trace to get nice kind of like error messages. But usually it's not really a concern because you're probably doing like a database call or something, which is a lot more expensive than generating a stack trace. So if you're doing purely synchronous work, then you probably should be just doing all of that outside of Effect anyway. It was probably just an oversight, to be honest. Oh yeah, I should have used it tagged error there. Um, the only difference between that is tagged error has better stack traces and you can like yield them directly. So that's the exact same thing as doing effect.fail. Um, not every time you're working with a function. So If you just have a plain effect, you obviously can't wrap that with effect.fn. So that would be a case we would use with span. But I feel like now that we've introduced the API, if you're doing a function that needs tracing, I'd probably always use effect.fn. Yeah. Yeah, so obviously promise is probably one of the more common types, but you might have like async callbacks, or you might return like an async iterator or something. Um, you can just like kind of adapt to the pattern. We have different APIs, and I'll go into a bit later, that cover off the different data types in JS. So it's just a matter of like tweaking the signature to fit whatever thing you're wrapping. Yeah. Uh, yeah, I guess when it comes to the error handling strategy, my take on it is I always start with a single error that covers everything, and only ever add specific errors when I actually need to handle them differently. Um, and that actually does happens not as often as you think. Most of the time, I just want a single error for the entire service. But if there are cases you need like to handle a very specific case, then you might need to create like another method in your service that kind of like focuses in on that particular use case. Um, I still might want to handle OpenAI errors. Like if OpenAI gives me back an error, then I might want to do something uh, like return a different response or log it. Um, but cases where you might want to add more errors if like you want to differentiate between network errors and like schema errors, and that would be the case where I'd start adding more error types to the domain. Yeah. Mm. Um, so generally in a service, you don't want to like leak other domains into that domain. So sometimes I might add like a reason here, network or like unknown. Oh, this is a schema. So here you would use schema.literal. You can either do it that way, or you can add like uh, an open AI network error or something. But the idea is like you kind of like transform the errors from the other domain into this open AI error, and just ensure that it has the metadata you need to like do the right thing in your kind of like your business logic. Does that answer it? Kind of. Yeah, yeah. Domain modeling is kind of like half our job as developers. Any other questions? Okay. All right. So now it's your turn. Um, the first exercise we'll be doing is wrapping an SQLite client. You can find the example at that location in the repository. Let me just quickly open it. SQLite. So I've already kind of like done the boilerplate for you. So there's effect.service here, there's an error type and some usage. So it's your job to add a use method and a query method that you can then use to kind of like consume the better SQLite free library from npm. And I didn't cover like adding other methods before, but probably query would be something like SQL string params, and then it would like use the client and do something. All right. And if you have a question, put your hand up or just yell out. So I kind of did it along with you, and this is how I would approach it. So this is because SQLite is synchronous, we don't need to unwrap a promise here. And it's kind of like going back to that question we had earlier, what if it wasn't a promise? But in this case, SQLite is synchronous, so we don't need to, we just grab the like return type directly. And because it's not a promise, we can just use effect.try instead of effect.try promise, which is very similar in practice. It did get a little bit complex here because in SQLite, or this particular library, if the statement isn't a reader, like isn't a select statement and doesn't really like return anything, then it throws an error. So we have to do this conditional check and like run it differently. This is kind of like showing, in some cases, npm libraries don't completely conform to like a use, and adding like another method that does a little bit of extra work to kind of like get back a nice consistent result kind of like pays off in the long run because it's a lot more ergonomic to use in like your app. All right, probably one thing I forgot here was our friend effect.fn. And then here we could do effect.fn dot query. And if I open Grafana, explore, then we run that. Of course, I didn't provide my tracing layer, that's why. We can see here like the query which then used sqlite.use. That's like playing into the observability piece. All right, let's go back to slides. So hopefully through that you got a little bit of an idea of what the use pattern is like and how it can be quite useful. And the next thing I want to go into is wrapping paginated APIs. So quite often like an API client will return like pages of data, and it's quite useful to know how to like approach this situation. And what I usually turn to for this is streams. So stream is a module from Effect which represents like a series of events or items, kind of like RxJS in some ways. And in particular for this situation, I turn to the stream.paginate APIs, which are like focused in on this particular problem. And in particular, I generally always turn to stream.paginate chunk effect, a bit of a mouthful. But what it allows you to do is you have like a cursor, and that cursor might be a page number or like the offset or the next ID to fetch in the page in the API stream. So that is this type parameter here. And then given a cursor, we return an effect that returns like a chunk of the data and the next cursor. And it's an option of the cursor because if you return option.none, it then indicates, hey, we've reached the end of the stream. You can stop here. And this is kind of what it might look like in practice. You have like, you start at page 1, and then that gets passed into here. So the cursor is the page. So we fetch the page with some effect, and then we kind of like wrap it in a chunk, which gets turned into the stream, and like the next cursor to the next cursor for the next iteration. So this would hit this, it would increment to page 2, and then kind of like start over again. So I'll quickly demo that. That is paginated. So this is our client from earlier. Oh yeah. So here we want to use stream.paginate chunk effect. So the first thing I'd usually do in this situation is kind of like look at the client interface and see what we have to work with. So chat.completions.list. So we have a look at this type signature, and OpenAI has this page promise thing that it returns here. I hope you can see that. Yep. And we just need to explore how we can use this to in our paginate chunk effect. So maybe for now we'll just chuck undefined in here. We'll have some cursor and then use client. So we looked here and we noticed there was a page promise. So we'll kind of like copy paste what we did for use. So now instead of like expecting a page promise back, we're now expecting the special page promise thing. And I need to add a generic here. So now instead of use, we'll do if client. And we'll write that and try promise. And we'll add our normal catch stuff. So now we've got to this point. So here I would usually like type, do like a quick effect.map just to see what I'm dealing with. So here we have this request ID thing. Request ID. Maybe we'll just look at this. Okay, I'm not getting any completion there. Page. Oh yeah. I'm just going to roll with this because I can't be bothered working around OpenAI's types. But oh yeah, the key thing is when you look at the OpenAI API, they expect a page promise with 2 generic parameters. And what we do here is first grab the page by evaluating it the first time, and then we use that as the cursor and kind of like loop around. So this is kind of like a weird one, but generally the kind of like steps is working out what the API returns and like trying to identify what you can use as the cursor, and then kind of like continually looping around and passing it on until you kind of like reach the end. So here we're checking, is there a next page? If there is, we return the cursor thing. Otherwise, we hit object.none. And because this expects a chunk, we do like unsafe from array here to turn an array into a chunk. And then here you can see it in action. So it's returning back objects. So we used stream.paginated chunk effect in that demo. We tracked the cursor using OpenAI's page API, and then added like tracing on top of that with stream.withspan. Yeah, you definitely can. I think I will cover that shortly, but there's like a stream dot from async iterable API. Yeah, yeah, you definitely can. So are there any other questions about that? I covered it quite quickly. Yeah, yeah. So usually you would put that into like the layer. So if I go to OpenAI, sorry, SQLite. So here you would then like kind of like move this here, and then maybe like create table like if not exists or whatever the AP thing is. So yeah. So this, if you've done like your layers properly, then this will be memoized and only executed once. In this way, either like the create table would then be part of your layer construction rather than wherever else it might be. Any other questions about anything? Cool. All right, and the last thing I wanted to kind of cover in this kind of library section is kind of like wrapping specialized API. So in the case of OpenAI, probably like the primary reason you're going to be using it is to like generate completions, and you might want to like stream those or something. So generally I try, if I find I'm doing like a very common thing with a library, I'll create a method just for that thing, just to make sure like the ergonomics are as nice as possible. Um, and I'll just quickly cover that. And this will like tie into like async iterable question that we heard earlier. Here's this one. Oh, that's this one, sorry. So that was our paginate method from before. So now the objective is to like, maybe I'll just, for the sake of time, just do the completion one. So like if you find you're just like doing this thing over and over again, then continuously having to like use like .use and then pass in the function might get a bit tedious. So here we'll create like a nice wrapper for it. So we don't have to like go through the boilerplate each time of going like .use, then client.chat.completions and all that kind of stuff. So we have a quick look at this. We can see that when we do stream true, that it gives back this promise of this stream thing. So ideally, like the API we want is just one where we can pass in like the messages and stuff directly and then like get back a stream. Maybe just for the sake of time, I'll just go through like the final solution. So the first thing I did here was like unwrap the promise of stream and then turn it into a stream. So this is kind of like a use, but for like OpenAI's stream model. So when you like call it, we get back this kind of like stream thing from OpenAI. And if we have a look at the types, we find that it like extends async iterable. So this is the case where we can like use one of Effect's kind of like built-in APIs for unwrapping JavaScript data types. And in this particular case, we'll use stream.from async iterable to turn that kind of like OpenAI stream from JavaScript land into like an Effect stream. And to like consider interruption in this case, we'll oh yeah, we won't really do that, but this stream thing has like an abort controller on it. And you can use like a built-in like finalizer API to call that when the stream ends. So if we shut down the stream early, this effect stream.ensuring thing will fire. And then we can like call the abort method on the controller that OpenAI gives us. And there's lots of different ways you can kind of like tie in interruption. Another way of doing it would be like using a scope and then adding a finalizer that calls abort. But probably won't cover that right now. But have we got any questions? And then to add like our final completion API, we'll then use that stream thing we made, and it will just like take the completion parameters straight in and unwrap the stream. And just to make it more ergonomic to use, we kind of like filter out the stop token that OpenAI gives us, so we don't get like a situation where we don't have any content in the like stream item. And this is kind of like what usage might look like.
Take a while. Is it still like a stream back?
Take a while. Okay. So the first thing we did was create like this stream helper, which unwraps OpenAI streams and then gives back an effect stream. And we did that using stream.from async iterable. And it's kind of like worth noting at this point, we have this type here. We have like an effect with a stream inside of it. And whenever you have an effect with a stream in it, you can like unwrap it using the stream.unwrap API. So now we have a stream, which kind of has the effect embedded inside of it. And then here we just added some telemetry spans. Yeah. So we then use that to get back a stream of chat completion chunk. And then this take while will only take items until we reach this like kind of like condition. So if the finish region is stop, and this when the finish region is stop in OpenAI, the content is like undefined or null or something, and we don't really want to deal with that in our business logic, so we kind of like filter it out here. Have we got any other questions on this? Yep. I, oh, the tracing. Explore. So when we look at the trace, there's our like our completion thing. So I just make that bigger. So we can see like everything took about 5 seconds. And there's like the stream wrapper that we made, which completion was using. So like when you wrap a stream of a span, it kind of like wraps the beginning to the end. So quick recap. So for like commonly used APIs in your business logic, it's quite beneficial to like create separate methods for those just to like improve ergonomics and like reduce all the like the .use clutter. And there's quite a lot of Effect APIs that you can use to unwrap JavaScript data types. Like in this instance, we use stream dot from async iterable. And you've probably noticed that sometimes this requires quite a bit of reverse engineering effort. You kind of have to put your like library hat on to like try like find out in the types how you can then kind of like unwrap whatever the npm package might be giving you to turn it into something you can consume in Effect. So in this case, we had to unwrap like that page promise thing, and that does require a bit of work, but it usually pays off a lot if you create like a nice API that is easy to use in your business logic, because it just makes everything easier to read. Any other questions? Yeah. Mm-hmm. Yeah. Oh yeah. So you kind of like peel off layers. Um, Potentially. And there is like a API called stream.toPull, and then you like pass in a stream here. And that gives you back like an effect that allows you to like pull chunk by chunk. And then when the error is an option.none, then you know you've reached the end of the stream. So that is one way of doing it, or you could probably have like some kind of effect that tracks some state somehow. Yeah. Any other questions? All right, now we're back over to you. And in how are we doing for time, by the way? 15 minutes. All right. So we'll make this the last, oh, we might have a bit more time after this, but going back to our sqlite exercise from before, let's try add like a stream API. So if you have like a massive table with lots of rows, you're not like shoving everything into memory. And just to like, I'm not sure if I dropped a hint in there. Oh, yeah, there's the hint. So I'll let you hack away at that for a few minutes and then we'll get back to the slides. All right, we'll call it there. I'll quickly step through my thought process when tackling something like this, and then we'll go to the back to the slides. So the hint was statement.iterate, and to get a statement, you first need to prepare. And if we look at the types, iterate gives us back an iterable iterator. And stream just so happens to have like a from iterable API. So we can then just like pass that along inside of like a use call and then use the stream.unwrap thing that we introduced earlier. And for like the observability piece, we can use like stream.withspan to add a span to that. And then when we run this, we get back like every item from the stream. And then if we go to Grafana, which has gone black for some reason. Oh, I'm not providing my tracing layer again. We'll just pretend it worked. Okay, let's go back to the slides. Cool. Was there any questions about that demo or from the exercise? Everyone looks good. All right. Probably the final piece of this is wrapping multi-shot APIs. And what I mean by that is that, like in some scenarios, you need to wrap an API that like invokes a callback more than one time. And like examples of that are like request handlers in Express, or maybe like an event listener, and if you're in the browser, or maybe it's like I don't know, a Telegram library that hits a callback every time a message is received. And quite often in these scenarios, you want to like access your services that you've defined in your Effect business domain. And another thing you need to consider is like you might be running these effects, but these effects might be taking a long time. And if your program is shut down, you like want to make sure like they're finalized properly, and like you just want to consider life cycle management to ensure like nothing leaks. And there's a few strategies for this. You can like directly fork a fiber inside of the callback using like effect.run something, run fork or run promise, and then subscribing to the result using a fiber has like .add observer, or if you do run promise, you can go like .then or await it. Or you can like indirectly fork a fiber by adding it to, in effect, we have like queue modules. So like every time a callback is fired, you can like put something onto a queue, and then like in a background task, like continuously process items from that queue. And if you need to send something back, we have like a module in Effect called a deferred. And that allows you to, it's kind of like a promise in some ways, but the deferred allows you to like send back signals to another location in your app. I'm not actually going to cover this section or this strategy, so I probably won't go into any more detail than that right now. Or another option is you can turn that callback, being called several times, into a stream, and then kind of like process that stream using all of the APIs from the stream module, which is quite powerful. And I just want to like focus on 1 and 3 in this workshop today. So the stream module has like a bunch of async APIs. And they allow you to create like a stream from callbacks. So like an event listener, you'll get like a bunch of events in the callback, and you can then wrap that in like a stream, and then do things like stream.map effect. So for every event, do some effectful thing, or you could do filters or reducing, all that good stuff from stream. And usually I always turn to stream.async or stream.async scoped when the callback supports back pressure. And what I mean by that is some like APIs return a promise that let you know when like it's kind of like flushed or what's the right way of saying this? Sorry, async and async scoped return a promise that you can await. So when the item is consumed downstream, you can then move on and consume the next chunk. And that ensures like you are handling memory well, because whenever there's like streaming and long running computations, you really have to be aware of memory and that you're not putting like a million things onto the JavaScript heap. And then there's this other API called stream.async push. And this is when like the backing API doesn't support back pressure in any way. Like event listeners don't support back pressure. So this is like designed for those cases. And generally async push is what I turn to most of the time. But if your source does support back pressure, then you can like pull back to stream.async.
How would you know that like the API support back pressure or not? In the doc, or like there's something to look for in the API signature?
Like an async iterable is one example of this because you can do for await, and then each iteration of the loop, if you like do something long running inside of the loop, it won't actually consume the next item until it does the next kind of like loop around. So that's one example of something that supports back pressure. Basically anything that you can kind of like say pause on while you kind of like await on a promise. Probably the easiest way is to demonstrate. That one. We'll make this the last like demo for now, and then we'll take a quick break. So here we have an event emitter or an event target, and we want to turn it into a stream here using a stream.async API. So because event emitters don't support back pressure, we'll use async push. And here you could use effect.gen or you could use effect.function. So async push takes some type parameters here. So you can do, say, things like this stream is going to succeed with void. In this case, it'll succeed with event. It might fail with an error. You can like specify those up front. Because this is like a callback, we can't like really infer those type parameters for you. So you do have to do a little bit of legwork and supply those. So here we'll go emitter.add event listener. Click. Event. And this emit thing that gets passed into async push has a bunch of methods on it. So you can say, please emit a chunk of items or a single item or like fail with an error. So here we're going to emit a single event. And then we can then pass it along to event listener. And in this case, we need to consider resourcefulness because you add an event listener, you also need to remove it. So in here, you can like add finalizers to perform the cleanup. So we'll do effect.sync and remove the event listener. So that's just like a quick example of how stream.async can turn like a event listener into a stream. Any questions? So this does touch on scope a little bit. This add finalizer thing will add a scope, add a finalizer to the scope, and stream.async push kind of like unwraps that for you. And so you don't need to like think about it too much. But in saying that, there are a bunch of like APIs that we provide to like help you unwrap JavaScript data types. So we unwrapped an event emitter, but there is an API that does all of this for you called stream.from event listener. And we've already seen stream.from async iterable. There's also stream.from readable stream, which is like the web standard stream. And from in our platform modules, we have like modules for unwrapping node streams using nodestream.from readable and nodesig.from writable. There's probably a few others that I'm missing, but these are kind of like the things you see quite often in app code. Cool, so we'll stop there. We'll take a quick break and we'll get back into it in about 10 minutes. If you have any questions, come and see me. I'll just stick around up here in the front. So in this next up, so we've covered off streams and turning like callbacks into streams. And the other thing that I mentioned when we went back to strategies is forking fibers directly in callbacks. So we'll try to cover that now. And we'll probably go a little bit faster now so we can get to the exercises, which this is the next couple of exercises are kind of like the core things I wanted to cover in this workshop. So there are a few options for running effects directly. Of course, you can use effect.run promise or run fork directly. But then you have the problem that expects like all your dependencies to be never. And maybe we want to use our services. So that kind of like leads us to the next exploration is effect.runtime. So what effect.runtime does is allow you to kind of like access the current runtime and kind of like specify the services that you want to add to that runtime. Maybe I'll do a quick demo of that because I don't think I'm going to cover it in my demo. So you might be in some code and need a runtime. You can go yield effect.runtime. And then in this generic parameter here, you can like specify what services you want to like put into that runtime. So never is nothing, but then you might want to put like the OpenAI client thing into there. And we now get a runtime with OpenAI inside of it. And what that allows you to do is use like the runtime module to like run effects with OpenAI in the requirements. So let's say we go declare const effect. Maybe it returns void, never OpenAI. We can now like pass it in and get our result, which in this case didn't work. Yeah, so that type check's fine. And like normally if you use effect.run, it would like complain, hey, you haven't provided OpenAI. But in this case, it wouldn't. And what runtime does is then like adds the requirements to like the parent effect where you extract it. So now like this effect has like effect void never OpenAI. So we're kind of like moving, when you do effect.runtime, it kind of like moves the services you specify to like the point where you construct it. Any questions about that? We'll just quickly move on. But there is still one problem with that. When you like run an effect, if it's like a long running operation, it's like it can leak. Like it could be like running and there's kind of like no way to stop it unless you like use like one of the like run promise can accept abort signals and run fork can call interrupt. But if your program shuts down, it will try to continue running, which might like cause issues. Might mean like when you try to shut down your server, it might hang for a long time. So we do have some modules effect to work around this, and one of them is called FiberSet. And FiberSet allows you to manage fibers in a more ergonomic way, and it adds life. It's kind of like effect.runtime, but then it adds like lifecycle management on top of it. So I kind of want to focus on the FiberSet module, but it also has some siblings, in particular FiberHandle and FiberMap. So it's kind of like a trio of modules that kind of have very similar APIs, but can be used for different scenarios. So when you're managing one or many fibers, these are very useful modules to ensure like your services are considered and the life cycle of the fibers is managed correctly. So fiber handle is useful for managing a single fiber. And that could be like a long running background task that represents like a single server. You might need to start and stop it. And fiber handle has some like methods in it for like starting a fiber and then closing it or like replacing it with something that ensures like the previous running operation is then like interrupted and then the new one replaces it. So it gives you like a bunch of APIs for managing a single fiber and kind of like the life cycle around that. Then there's fiber set, which is for like managing multiple fibers. And this is pretty much my go-to anytime I have like a request handler that needs to run lots of effects as requests come in. I will use fiber set to like track all of those. And then when we go to like shut down our program, it will then ensure like all of those, if any of those things are still running, that they're then like shut down properly. Like for example, you might have an Express server and you're putting all your effects into a fiber set. When you go to shut down that server, it will ensure like maybe a status code 499 is sent back before the server is shut down. And then there's fiber map, and it's quite similar to fiber set, but you then can like index like your effect runs by a key. So let's say you have like a well-known set of background tasks that you want to manage, and they might have like IDs like ABC, EFG. You can like then target specific fibers and like add them, like remove them, and then when your program goes to shut down, it ensures like the entire map is like shut down correctly. So to illustrate fiber set a bit more, I'm going to do a demo around Wrapping Express. And probably for the sake of time, so we can get to the more interesting examples, I'll probably just go straight to the solution and then go through my thought process. Or maybe I'll live code it. Let's go. So whenever, if you're wrapping Express, probably the first thing you'll want to do is convert the listen call. I'm assuming everyone has like some familiarity with like HTTP servers or Express, but if not, just let's go for the ride. So the first thing we can do is just like move all of this into an effect, which doesn't really do anything off the bat, but it's a good start. And then I can't remember if close is there. No. And then the first thing I would do is like, I actually, for the sake of time, we'll just go straight to the solution. So the first thing I do is like think about like the resourceful aspect of creating a server. So when you do express.listen, it will then give you back the server here. And then in our like finalizer, we can say we want to close the server when this program shuts down. So we've got a server.close here. We're using effect.async, which is what you would use whenever you need to wrap like a callback API. And that gives you like this resume thing. So when the callback is fired or when the close is complete, we pass, in this case, we're passing the result to resume. So what will happen here is when our program starts up, it will call listen, and then when it shuts down, it will call close. And close will make sure like everything is shut down cleanly. And then when it comes to the request handler, we are, first here we're like accessing OpenAI, and then we're adding an endpoint. And then probably the key thing that we want to cover is we've got this fiber set here. And the fiber set module has this API called make runtime. And this is kind of like very similar to the runtime module that we looked at further. Like what it essentially does is this. And then does runtime dot run for. So they're kind of equivalent, but the fiber set one is adding like the lifecycle management. And if we look at the type signature, we can see here that a scope is added right here. And that scope is what is kind of like tracking the lifetime of the fibers. So when that scope is closed, it will ensure like any fibers that are still running are shut down. And I kind of glossed over it, but a fiber is just essentially like a running handle to an effect. So when you run an effect, you kind of like get back a fiber. And then we use it inside of our Express app. So we register a route like normal, we get a request and response. And then instead of like having like our traditional like promise kind of style API, we're using effect.gen, and we're running like our completion stream here that we defined earlier. And then for every chunk of that stream, we're calling back to Express and writing that chunk. And this run fork here is from the fiber set .make runtime. So when we get a request comes in, it will run that effect, put the fiber inside of the fiber set, and then when it finishes, it will then be removed because it has completed. You're just going to have to trust me that it works because we're going to move on. It works. I know what I'm doing. Yeah.
Difference between just using like a plain what happened if I don't use like this when I want to control C in my program?
Yeah. Yes, it would hang, because if I did something like effect.never here, which would never complete, and was using a normal runtime, there would be like a handle open in the background to like effect.never behind the scenes has like a set interval to keep the process open while it's running. And if you're using a normal runtime, the life cycle isn't tracked, so it'll just be continuously running in the background. So when your program tries to shut down, it will just be like leaked essentially and running.
But let's say I'm not using it right now. I'm just like I'm talking to the brain.
Yeah.
Like what would happen in like real life?
Basically, the fiber would not be shut down correctly. So if you were handling an interruption case in your handler, and wanted to respond, say, send like a status 499 when interruption happened, you couldn't really do that in that scenario because it would close the server before it hits that point. Does that make sense?
So if I just use run for, not like the Bible for,
Effect.run for, yeah.
yeah,
Like,
run for. If I just do that, when I hit Control C on my server,
yeah.
it will just like shut down the.
Yeah, it won't be a graceful shutdown at all. It will just like kill the server because we're not even thinking about the fibers.
Unless I've done
Yeah, like unless you're like manually getting the fibers and like tracking them yourself somewhere and shutting them down. Yeah, so like the manual way of doing that would be like defining like fibers and having like a set that tracks them and adding a finalizer that goes through that set and make sure everything is shut down. In here? That won't really do anything because the finalizer would be inside of the request handler, not. You need to add a finalizer somewhere to connect like the construction site to the handlers. Does that make sense? So when the layer or whatever it is shut down, it also like shuts down the fibers with it. So the fiber set is what connects like the construction point to the request handler point.
Sorry, one question, like, what if like not like effect run fork, like there's a run fork scope to it?
Yeah, so another way of doing this is run fork. And there is a scope argument in here. So this is another way of doing it, and then you can access the scope and then pass it in. So that is very similar, but the fiber set is a little bit more ergonomic and has some more useful methods. And probably not that it's that important, probably performs a little bit better because it's just a simple JavaScript set in the background. Cool. Any other questions about that? Yep. So it's up to you to handle the errors in this effect. The fiber set is only concerned about running things. It doesn't have any built-in stuff for error handling so it's still up to you to do like the business logic of handling errors and mapping that into responses correctly. Yep.
In like like, do you want to interrupt the response and like send like a 499 or signal? Like, do you want to just wait for like an explanation, like finish the result and then like close your pod?
What you can do is you could have like, if I want to make sure like this request is always run to completion, I can mark it as uninterruptible. What that means is we're starting to get into interruption here, which is a bit of a rabbit hole, but by putting effect on uninterruptible here, even if the server is shut down, this particular run, it will hit the uninterruptible region and then it will ensure that this effect runs to completion.
Is it acceptable interruption? Like, should we do that? Like, if I want to wrap like an effect, like an express app,
Yeah.
should I wrap like follow this pattern and like use like uninterruptible at the end?
I'd say do it with care because as soon as you start introducing uninterruptible regions, you'll find that, like, in some situations, you may be forking fibers inside of this effect, and uninterruptible is contagious. So if you're spawning more fibers inside of the fiber, they are also now uninterruptible. So you just have to be very careful. Like you might get yourself in a situation where your shutdown will hang until Kubernetes or something like kills it.
But the alternative is like, if I deploy frequently, like I'm gonna kiss like a interrupting my request.
Hmm. Um, yes. Yes. So you just have to think about that and kind of like determine what handlers I want interruption to be kind of like send to 499, or I want to make sure like these are uninterruptible. So it's kind of like up to you to decide when to use uninterruptible or not. Yeah. Yes. Yep. Yep. I think fiber set has a size. Yeah. But make runtime is like a shortcut. What it's actually doing is going fiberset.make, which is, we get fiberset, and then going fiberset.runtime. And then in here you would specify like the requirements that you want to add. All right. So, oh yeah, I got it backwards. So you first create your fiber set and then generate like the run fork thing. And then by doing it that way, you can then use like the rest of the fiber set functions to do things like size, or you might want to add fibers manually, or you can like await for all the fibers to complete. There's like a bunch of useful APIs in there for like working with a fiber set. Yeah. Cool. So we use the fiber set and we use like effect.acquire release to make sure like the server is closed when we shut down our program. And then we showed how we use OpenAI in our route to, in our request handler to talk to OpenAI, which was an effect service. But there's still some issues here, and Maxwell did a great job of showing us why layers are great. And it answers these questions, like the composability is still a missing piece here. We might want to test different parts of our application in isolation. And we also need to improve error handling because we weren't doing any. I'll just quickly cover this because I want to get to the exercise. Express later. So there's our, oh yeah, I need to change my thingy. So we're now wrapping our Express app in a effect.service. And what this allows us to do is then use the app in other parts of our application as a service just by yielding this tag. So like before, we're doing the listen call here and then adding the finalizer to close it. Yeah. I added this add route helper that you can then use in the exercise later, but this is kind of like going back to holistic thinking. And this does considers interruption, kind of like the lifetime of fibers and error handling. So we've got our, maybe I'll just quickly run through this, but we've got this run fork thing from before. And then this little helper will kind of like add the route to Express for us, and then add our observability for us. So we'll execute. So you pass in this handler function here, which will take the Express request and Express response, and then you can return an effect. So we get our effect, we add a span to it with some metadata, and then what we're doing here is when that handler finishes, if we haven't written a response for some reason, it will just make sure like one is sent. So if the headers haven't been sent, it will send back one. If it was successful, then it will send back an empty response. If there was an error, it will just return a 500. And if for some reason we haven't like sent a body yet, then it will just send nothing. And then like if there was an error for some reason, it will log it with some metadata. And usually when you're wrapping things like Express, it's useful to add like helper methods like this. It does quite a bit of work, and it is quite complex, as you can see. But if you can put in the extra work up front, then all your code, when you go to like migrate to these effect helpers, is much more easier to read and understand. Otherwise, you would be like repeating all of this over and over again. And I am covering this very quickly, but feel free to copy paste this when we get to the exercise. And if you have lots specific questions about any of this code, come and see me after the session. So this is, now that we've created this, and at the end here, we're like returning our Express app and our add route helper. So now that we've turned this into like a tag and a layer, we can then kind of like split our app into more layers, into like parts and chunks. So like, for example, this could be like home routes. And what we're doing here is we're accessing our service, and we get back the Express app and our add route function. And we're also accessing OpenAI in here. And then instead of what we had before, we're now using add route to add like a get request on the completions route. And we can use like the effect, we can like return effects directly in here. And you can use effect.function, or you could have like a function that returns an effect.gen, or whatever you prefer. And then our helper will make sure like all of like the holistic thinking points that we went over before are considered. Like if this gets interrupted, then this request.onClose will fire, and then we interrupt the fiber. So let's say like this is a long running request and they close the browser tab. The request will close and it will send the interruption signal back to our effect and like make sure it's shut down. And that way, like if you're running like an expensive query to OpenAI or Anthropic, it's shut down and you're not wasting tokens, those precious tokens. Cool. And you just have to believe me that it works. Yeah, questions? So here I'm creating a fiber set per handler. And the reason for that is I'm considering requirements, and each fiber set will have like a different set of requirements. So, but I do want to ensure like the life cycles of those fibers is attached to like the layer itself, not like that's the only sensible place to like attach it to. So the fiber set, kind of like we put it here because we want to make sure like the services that we use in our handlers are then kind of like they're captured properly, if that makes sense. Cool. Yep.
What is the difference with using like I want for I'm using like a effect run from mice on each handler.
Yeah.
What is the difference?
So I'm using run fork here because I want to do like this interrupt thing here. So run fork gives you back a fiber which has like a bunch of useful methods on it. Like you can add a observer to it. You can interrupt it. There's like a bunch of things on here which probably goes out of the scope of this, but it's kind of like the most low-level way of running an effect. But you could also like actually. There's also make runtime promise, which is kind of like a run promise if you need a promise back. But here I'm going to a Firebase so I can like hook up interruption properly. Yeah. Yeah, so if you did run promise, I think, I can't remember. I think it accepts a abort signal. No.
I'm not talking about paginated, like
Oh yeah, I'm just like,
effect.
so effect.runPromise, the way you handle interruption in that scenario is, you can see this abort signal option here. So that's if you need to interrupt a run promise, you just need to pass an abort signal.
Like using like a 5% and like poking versus like using a run from max.
No, they all perform pretty similar, yeah. Any other questions? Yes. Yeah. No, we're all about layers here.
This is the situation where we have an express where we are creating the layer, but we need the layer itself.
Yeah.
There are sometimes the situation where you cannot add root after you already the list.
Okay. What you could do is pull, like not do the listen call in here and have another layer that does the listen call. And then just make sure that is the last thing that is kind of like run. Any other questions? Cool. All right, so just to recap, we now switched to using layer for like composing the different parts of the application together. What that allows you to do is like have like a separate layer for each kind of like portion of your domain without having to like add all your routes in a single place. And we added the add route helper, which considered all of the different kind of like facets you needed to consider when thinking holistically in effect. So like error handling, interruption, and observability. So we added the spans. So whenever a request comes in, we'll then see in like Grafana like traces for every request. So now it's your turn. Here we have an exercise or an express app. Let's open it. And there's a to-do list at the top. So the first three things on the to-do list are things kind of like the kind of things I want you to do first. But I've added like a bunch of optional challenges and advanced challenges if that was too easy for you and you want something interesting to tackle. I do want to get into later on in this workshop. I'm going to look at React and how to integrate into front end. So I'll probably spend about 15 to 20 minutes on this. And then in your own time, you could work through the more optional advanced challenges. And of course, all of the team will be around for the next couple of days. So if you like working on it in your spare time and need help with something, then we'll be happy to answer questions. But go for it. Yes. Yeah. So fiber set doesn't have any capacity. Doesn't have any capacity options. Mainly from a simplicity of API. But if you needed to like cap operations, then you probably at this stage need to track the count yourself somehow. So when you like run something, increment a counter, and if it's over a certain amount, then just like error immediately. Yeah. We do have some things for like tracking capacity of stuff, but it's more like our cache modules, and we have like a module called RCMap, which like is for tracking resources. And those things do have capacity options, but I don't think we have anything for like fibers. Yeah. Good. And for sqlite, just feel free to copy paste your like the sqlite solution from earlier, and use that as an effect service. Probably a key thing to note here is try to do it in a way where you're not modifying any of the existing handlers first. And that kind of like gets you into the thinking of, I already have an Express app, but how would I just like migrate one endpoint at a time? All right. I was starting to move into some optional tasks, but hopefully that give you a little bit of a taste of what incremental adoption might look like. Does anyone want a little bit more time, or should we move on so we can get into like front end stuff? Everyone's good. Okay. But yeah, feel free to hack on that when you have time. And if you wanted help with any of that, then just feel free to hit us up during the conference. But maybe if I just go over the quick solution I came up with. So I just copy pasted the Express app service from earlier. But the only addition is I added like the JSON middleware in here. So you could add like your middleware in here, or you could add it in another layer. It's up to you. And that was from before. So initially for existing routes, I just like copy pasted my routes into it, and then just use the Express app from the Effect service. And then I didn't have to change any of the routes at all from earlier. And then just one by one, I used our add route helper to turn them into like effect functions, which then use the SQL client service that we defined earlier. And then I use that to run our queries instead. Well, the first thing I did was add the update route in like a separate layer. So if we wanted to, we could like test this completely separate from like the rest of our app. And this kind of alludes to what Max was saying earlier. I'm like locally providing dependencies. So if you look here, our update route has like no requirements. If I was to get rid of that, it would have requirements for our Express app and our SQL client. And if we don't locally provide, it just means like in here, you have to like add a bunch more like layer.provides for everything. But when you like locally provide things, you just need like a very simple and clean merge all for all of your layers. And then you might like provide some additional stuff like tracing on top. And then the layer.launch. Cool. Any questions about that? Yes.
If you provide the layers locally, will it create only
Yes. So layer.launch will build all the layers once and then use that memo map thing to make sure, like, even if you provide a layer in several locations, if it's already built, then it won't build again. Any other questions? All right. No, that's not my screen. There we go. All right, front end. So when we approach using Effect in the front end, it's quite a different approach. Well, similar concepts, but a different approach. It's quite like in the example we showed before, we controlled like the main entry point to our program. Like we had our like layer.launch, which controlled the entire application. But when it comes to the front end, it's kind of like you're at the mercy of the framework to when you can run your effects. Like React takes over your main when you do like the React DOM dot render, whatever it is. So we can't use kind of like the layer.launch. We can't use like pure layers for our kind of like entire application. There probably is ways to do it, but you can talk to Johannes about that. So I'm just going to give a few strategies here of how you can run effects in React. So probably the main, this will all revolve around today is using a managed runtime. What a managed runtime allows you to do is take a layer and then turn that into a runtime that you can use to run effects that use those services. So it's quite similar to FiberSet in a lot of ways, but you pass in the layer and then it gives you back the runtime. And then you can use React's context API to like pass the effect runtime around. And what that allows you to do is kind of like when it comes to writing tests, you can then inject your own your mock managed runtime to perform like component tests and use mock services. I've had a few questions already at this conference about EffectRx, so I'll give it a brief mention. It's still an experimental package, but that also allows you to kind of like run effects. If you've heard of Jotai, which is kind of like atomic state management, it kind of like follows in the footsteps of Jotai and allows you to kind of like do, it's kind of like a state management library, but also allows you to run effects. And it provides a couple of integration packages. So the RX core is framework agnostic, and then it has like a React binding, and it also has a Vue binding. So manage runtime allows you to create a runtime from a layer. And here is like a quick example. So here we might have an OpenAI layer from the service we were looking at earlier. And then you like just pass it into make and you get back this runtime thing. And then we have an effect that like requires OpenAI. And then we can just do runtime.run promise, pass an effect, and there won't be any type errors because we have passed in the OpenAI layer when we constructed the runtime. So I'll stop there and ask if there's any questions about managed runtime or if it's tracking all right so far. Cool. Yes.
Once you like create your
No, and I'll probably go into a little bit more detail about having like multiple managed runtimes, and like each represents a different like portion of your domain. Like ideally, you wouldn't have like one huge managed runtime, because then it makes testability quite hard. Because if you wanted to like provide a managed runtime to a specific component when you're testing it, you would then have to provide mock versions of all of your services. So you want to be a lot more like targeted if you want to keep testability in mind. So Max mentioned memo map earlier, and this is like another key component I think you have to consider in front end. Usually when you do effect.provide, it does creates a memo map per every time you call .provide. And that's why Max was saying earlier that you should only have one effect.provide in your program. And that way you only have one memo map, and then every layer gets memoized correctly. And it's kind of like a black box data type. It doesn't really have any methods on it, but it's just something that we use internally to like track layer memoization state. And here is like example of using it kind of like with managed runtime. So managed runtime.make takes like a second argument here, and that accepts a memo map. So what you can do is create like a global memo map, and every time you create a runtime, you can pass it in. And what that ensures is, if you, in this instance, if I use runtime A and runtime B at the same time, the OpenAI layer will only ever be built once. And that ensures like layers are memoized even if they're used in different runtimes across your React application. And that's quite important if you want to make sure like your services are only ever built once, even though they're like used in different runtimes and different parts of like your React application. So in layer we do expose memo map, and so you can create your own one and like pass it around. So I'll give a quick demo. So here I have like a very basic React application with, I'm sure a lot of you are familiar with React Query. I will be using that to like run promises and make sure like it's cached and we don't get like the double renders that everyone knows and loves with React. Maybe you don't love them. So here we have just kind of like a fake call to the OpenAI platform, and it's just ensuring that like there's no type errors in our UI. So I will shut down Grafana and run that. Sorry, that's the exercise we want the demo. Thank you, plural. So here's our fake data coming in, and then I'll quickly show you what you can do around stream and how you can integrate streams into React. So the first thing we need to do is we'll just approach this incrementally. So first we'll pull in manage runtime, go make, and then pull in OpenAI. Did I put that locally? Yeah. And then we'll pass in the layer, our effect.service. Now we have a managed runtime that gives us access to our OpenAI services. And we'll just do the memo map thing now before we forget. Effect.run sync layer make memo map. We only have one runtime right now, so it doesn't really make a difference. But if we started adding more runtimes, the memo map becomes more important. So right now we won't use React context, and we'll just like run some effects directly. So in here, we'll go runtime.run promise because React query expects a promise. And then we'll do an effect generator. And then in here, we can now access our OpenAI service. So now we have OpenAI here. And we can go, so we don't want to stream here. We just want a normal completion. Let's just use client signal, client.chat.completions, and it's .create. Model. Sure. All right. And then back to holistic thinking. Let's pass our signal in. Actually, so React query actually passes you a signal, and the runtime.run promise call allows you to pass in a signal here. Yep. So what we're doing here is like handing the signal from, sorry, I've got a, okay. We're taking the abort signal that React query gives us, and we're like passing it along to run promise. And that will just hook into your React queries cancellation model. So we've got like a nice integration there. So now after that, we should, no, we've got an error. Oh, we're missing API key, of course. Oh yeah. Okay, so for Vite, I think it does environment variables through import. Let's go provide. Let's just do it here. Config provider. So when working with Vite, you can use this config provider from JSON, I think it is, and then you can go import.meta.env. And now we have a config provider that's like reading from Vite's environment thing. And then here we can go layer.set config provider. And hopefully that works. There we go. So that is like a really basic kind of overview of how you can integrate effect into components. In this case, React query. You create a managed runtime, and then you use that runtime to kind of like execute your effects that might use your services in your application. For stream, maybe I'll just look at the solution. Yeah, React solution. For stream, I'm just using a use effect here and using a React use state just to like keep track of the chunks as they come in. Looks like in the solution I created a helper. So when you get to the exercise later, you can come into here and I've added kind of like a helper that kind of wraps up all that manage runtime stuff for us. So that's the config provider that you saw earlier that takes stuff in from Veet's style of environment variables. Here's our memo map. And so the things I've added on top of the manage runtime is React context. So we create a context for our runtime. So this function here takes in another function which creates a layer. So like quite often in frontend, you want to like create a layer given some pre-existing state, like you now have the current user, you may want to create some layers from that current user. So here we have a function that, given some arguments, returns a layer. And then we create a context, React context that represents the runtime for that layer. And then here I've just got a provider that wraps the React context provider API that kind of like manages the lifetime of the managed runtime. So the managed runtime has some other methods on it, like dispose. So what this is doing is we're creating the runtime in like a use memo with the dependencies, which are our arguments to the function. And then when the component unmounts, our provider unmounts, it's like disposing the runtime. So if there ever is a case where a layer then becomes unused, the memo map is actually smart enough to like shut it down and close all the resources. So let's say you might have like or an authenticated section of your app that's using some layers that depend on the current user, and then maybe they log out, and then like the authenticated section of your app gets unmounted by React, then all the layers will get shut down and all the resources will be cleaned up. And then here is like the use context call. So if you're familiar with React, this is kind of like how the context API works. And then also in here, I added just like a helper function for creating like React query options. So here we like pass through a query key and like create a query function that does what we did before, where it like passes along the signal and some other like passes along the options as well. I'll stop there. That's quite heavy. So if there's any questions about any specific things, far away. Cool. So if we go back, so now what that looks like in practice is we call that make React runtime thing with a layer, and we get back the object with all of that stuff in it. And then in our app, we would like add the provider to our component tree. And if that had arguments like user string, we would then have to provide it over here like. So now that we have that the kind of like React contents provider in our tree, we can then start like using the helper methods on it, like use query options, or in the case of stream, we can then like extract the runtime at any point. And then when it comes to testing, we can like kind of like inject our own like custom runtime. with like mock services in it. So here we could do like manage runtime, and then insert some like test service in here. And then for the stream example, so going back where we left off, here I'm using the runtime.runCallback API, which returns, let's just make this a bit clearer. So when you do effect.runCallback or manage runtime.runCallback, you get back like a cancel function. And then we can like give that back to React to say like, when this is cleaned up, call cancel. And that's going back to holistic thinking, we're getting into interruption here. And that will just ensure like the effect is cleaned up when the component unmounts. And here we're using the completion stream API that we defined earlier in the workshop and unwrapping it. So we're accessing our OpenAI service, getting the stream, making the stream, unwrapping it, and then like here we're accumulating the chunks. So we always have a list of all the chunks that we've received. And then we just set our React state here. So because that API returns one chunk at a time, we need to make sure we're creating like an ever-growing list of chunks so we can render all of the content.
Setting in state, right, in the React state.
Yeah, so when we get the list of chunks, then we're setting like this array of string here.
Set chunk, you could get like a function that play it in like append, right?
Yeah, you could do that as well, yeah. So you could get rid of that and get each individual chunk and then go like, yeah, set state. Oops, set chunks array. No, that's supposed to be delta. And we'll just cast that. And then if we run that, React solution, there's our chunk streaming in. Cool. Any questions? Any other questions? All right. Where's my slides? So we used manage runtime to consume effect services, and we use like React context to like pass it down our tree, which means we can like test individual components separately. And that way you can have lots of managed runtimes in your application, and like they can be quite targeted. And because we supplied that memo map, it means like services won't be duplicated and they'll only build once, which I mentioned here. And then we also pass the abort signal from React query to the run promise call to make sure like it's interrupted properly and all that. And then we did a quick overview of how to integrate stream using useEffect. Any other questions? Yes. Yeah. Yeah, so it's a good question. And the question is, if you have like a set of schemas, where do you put those essentially? I would probably, if you have a mono repo set up, I would have a package just for your schemas. And the reason for that is you obviously don't want your server in your front end. So you have a separate package, and then that way you can share them between the back end and front end. Yeah. And we have, obviously have been covering incremental adoption here, but we do have packages for that are cool. We have a module called HTTP API in platform that is like schema first, and it allows you to like derive clients from schemas. I've had a few people ask me about RX. Lift your hand if you want to see like Effect RX. Oh yeah, we got 2 hands from Max, so let's do it. I'll quickly show you what that might look like in Effect RX. It is an experimental package that's undocumented, but because so many people have asked me about it, I'll show it today. Woo. So here's our OpenAI service from before, and it's exactly the same in our app. Okay. So instead of manage runtime in Effect RX, there's this thing called rx.runtime. So we're importing Rx from the React package. And then we're just going rx.runtime, and then we're passing our layer. So far, that's exactly like the manage runtime. We pass in a layer and then get back this runtime thing. But Rx is automatically handling that memo map stuff for you. So no matter how many runtimes you create, your services only get built once. And then from the runtime, you can like kind of like execute effects. So here we're going runtime.rx and then passing in an effect. And it's exactly the same like as our example earlier. We're just calling the OpenAI client and then returning the content. But the only difference here is we're using like rx.family. Maybe I'll actually do something a little bit different here. Oh no, that's fine. So usually let's say you might have like a text input somewhere in your application. You could have like input content Rx, which is it's like a string that you want to track. So rx.make kind of like returns these things that you can like, and I'll show you the React APIs for them in a minute. But rx.make has a lot of ways for you to create like these reactive things, like just like Jotai, if you're familiar with that. And they're kind of like handles. They're just kind of like context.tag. They're just keys really to this big kind of like state store. That's one way of thinking about them. And then here we can go content equals let's get rid of that for now. So rx.make also gets passed like this context object, and with that you can like get the state of other kind of like handles. So here we're getting the content for this guy, and then we can like pass that along to our service call. And because it's reactive, whenever this changes, if this is running, it will get interrupted and then it will rerun with the new content. So it kind of like is a reactive way of consuming effects in your front-end application. And if we look at the usage of it, we could have like a function completion input. So in the React package, there's like a bunch of hooks for consuming them. Use Rx is one of them. And then we can pass in like this Rx handle. So now, just like use state, we've got the current value and a way of like setting it. Cool. Thank you, Copilot. And now we can add that into our component tree. And Rx also has like suspense integration with React Suspense. So what will happen here is if the effect is in a running state, this will suspend and trigger the fallback up here. Then when it completes, we'll get back like a result.success. And a result.success contains a couple of things. It has like the current waiting state and also like the current value. In this case, it's string. So if we start typing again in our input, it will use the previous value but set waiting to true. Very similar to how React Query works. And then when that finishes, it will replace the content with the new content. But we're only really interested here in the value. So we see how that works. What's going on here? Hey. Looks like your message was empty, thank you. Hello world. And then that caused the effect to like rerun, and then once it had finished loading, it replaced the content. So maybe I'll just illustrate the waiting. Value. And then maybe in here, if we go waiting, loading, otherwise loaded. That works. I'm not a front-end dev. Do I need to do string concatenation here? So much brain power required for this. Just give me my backend services. I think we're close. There we go. Oh, we don't have our value anymore. Yeah. There we go. Loading, loaded. So you can kind of see how Rx is quite reactive in its model. And then when it comes to streams, I'll just quickly cover rx.family. So React works by reference. So if this reference is stable, it will mean it will always look up the correct location in the state store. So if you are dynamically creating like reactive handles, you need to make sure the references are stable, and rx.family will help you with that. So it kind of like looks at the arguments and then ensures like it's always, if your arguments are the same, you're always getting back the same like reference. And that ensures you're always like pointing to the correct location in like the state management store. But what Rx runtime.rx also allows you to return a stream. And like before, we're calling our completion API, like unwrapping it, turning it into a stream, and then accumulating the chunks. And what Rx will do will continuously consume the stream and always give you like the latest value. So here we're again using suspense to consume it, and it will give us back a chunk of chunks. And then we're turning that into markdown text and streaming it back. So the result is exactly the same as before, but it's a bit more like ergonomic. Like we just have this nice hook call. We don't have to like manage the stream and like run the chunks and perform the state updates. It just kind of like gives you the latest value back from the stream. So that was a very brief overview of RX. So it is, yes? So you can continue to use the previous value while it's loading the next value. And then you can show like a loading spinner or something while it's fetching the latest value, and then or swap it out. Yeah, so it will only trigger the fallback on the first load, and then the other loads, it will only update the waiting state. There's also, I think there's an option in there to like always trigger the fallback. Yeah, there it is. Suspend on waiting. True. And that will always hit the fallback, even if you have a previous value. Any other questions about RX? Yeah, go for it. Yep. React server components. I didn't really think about React server components while preparing this, so yeah. Yes. Yeah. 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 So just to, the question was having like a layer that's only valid when a user is logged in. So if we go back to this example, in here you could have like current user, or maybe we create another one, and maybe this represents some like your logged in service, some other logged in service, like I don't know, maybe like dashboard runtime. And then in here you can like take in like the current user maybe that you would receive from elsewhere, and then like pass it along to some layers like dashboard layer, and then here's the user. So this won't be built straight away. It's still waiting for the user to be passed in. But when you go to add it to your tree, you'll need to like pass in the current user. And then at that point, it will be built. And because we're passing the memo map around, it will ensure like if that's using any other services that are already built, they don't get built again. And it kind of like handles the lifetime for you. And if for some reason this like gets unmounted in that thing here, when the component is unmounted, it disposes the managed runtime and cleans up the layers if they're not in use. Does that answer it? Yeah, cool.
So you're basically
Yeah, so it's essentially tying in the life cycle of your layers into like React's component life cycle. And RX is pretty similar as well. If it detects that an RX.runtime is no longer in use, it will actually clean it up. And you can also set like timeouts for that. So if we go RX, this one. So here we have that runtime from earlier, and you go pipe rx dot set idle time to live, and you could say like 5 seconds. So if this runtime hasn't been used for 5 seconds, Rx will then clean it up and clean up all the resources. Any other questions about managed runtime or Rx? Yes.
You have a service that need access to the current user, like a token error, for example, you have an error
Yep.
and if the user logged in, you want to report, you want to add some context, like who is the user.
Mm-hmm.
If there is not logged in, you can't add some context. Like, you want to use the same service. Always want to use like the same like error service, like report it. Um, right now with the solution, I have to like pick and choose which management time I want to use based on like whether I'm like logged in or not.
Right.
Like either a way to unify that and like just use like one, yield one thing so I can use the service for that.
I don't quite follow, but you can like store the current user state in like a subscription ref or something, or like some kind of. You could also track it in like an RX where it's like an option of the current user. And then in your effect services, you can actually like set, can you? Probably better to do it in an effect service. We have like a subscription ref that where you set the current user and then the other parts of your apps listen to that maybe. There's options of doing it. That's kind of like the thing with front end. There's a lot of ways to skin the cat. Cool. How are we doing for time, Max? So like a hybrid approach of you have the option of user, but then you also have a concrete user somewhere. Okay. We're in Q&A time now, or? Okay. So I did have an exercise for you for like migrating this Pokemon app to Effect. I'll quickly run through it now, but I don't think we'll have time to like do it together. So it's under exercises, exercise React X service. X. England. Here it is. So in this app, we have create query like before, and it has the search string component, and it has a to-do list in there. So right now, I'll just open it quickly. Exercise. Nailed it. Yeah. So it's just like a search box, and then if we had audio, you'd be able to listen to Ditto do a thing. Yeah, it was beautiful. Or we could go Pikachu. But at the moment, it's just like all plain React. And if we go to the to-do list, the items we like create like a Pokemon service that wraps the Pokemon API, and then like create like a managed runtime that allows you to like run that service in your components. And there were like optional challenges like using schema to like decode the API responses or use the platform HTTP client. So we're not going to have time to go into detail on this, but if you want to tackle this in your own spare time, go for it, and then hit me up if you have questions or need help with anything, either on Discord or hit me up if you see me around the conference. All right. So that's all I had for you today. I think we're going to head into Q&A for the entire workshop now for a little bit. Is that right? Oh, we're at that time. Yeah. So, yeah, cool. So you're free to leave now. Thank you for being part of this workshop. It's great to see everyone here. Hopefully you learned something today. Yeah, and we're going to head into a bit of Q&A, but if you need to be somewhere, feel free to head out. Yeah.